next class. Expensive thermodynamics, right? How much is the expected average? Zero, huh? Somebody said zero. How was the first quiz average? Huh? 4.5. It is less than 4 this time. How much is the highest? What was the highest first quiz? Highest is same, I guess. Highest is same, but average is less than 4, even less than 3.5. So maybe we can get update next class. Okay, attention please. So we'll be starting now numerical analysis. Attention please. So for the numerical techniques, what we are planning to do, we have seen the vector space and functional space problem. So we want to solve them. Those vector space and functional space problem by numerical techniques. We have done the first part of the class, or majority of the part of the class. We have done by the analytical technique for the vector space and functional space. So numerical analysis, same thing. We will be solving LU equals to F by numerical techniques. Numerical techniques. But when you use numerical techniques, when analytical solution is not possible, or what actually happens? We go for Ax equals to B. And what's the analytical solution for Ax equals to B? Any idea? Analytical solution for Ax equals to B? We have done it already, right? How to solve analytically Ax equals to B? X equals to A inverse B is not the analytical solution. There are some ways we can actually found out in the BTech first time mathematics. Cramer's rule, excellent. Cramer's rule, which is expensive for even 10 by 10 matrix. This Cramer's rule will be expensive for 10 by 10 matrix. I don't want to teach an operation count a number of flops in computer. That way generally I talk about, I discuss in my numerical analysis course I am not offering. So but here I can tell you that it is actually pretty expensive for 10 by 10. And in that case, for that kind of system, numerical analysis will be very helpful, and we solve by numerical techniques. So if the system is linear, X equals to T, the system is linear, definitely analytical solution is possible, but the things become expensive. Cramer's rule becomes expensive because Cramer's rule requires the finding determinant, right? You need to find determinant. And determinant, you have seen that, how many terms will be there for 3 by 3 matrix to find determinant? 3 factorial, not 6, 3 factorial. 4 by 4 means 4 factorial. 5 by 5 means 5 factorial. 10 by 10 matrix means how many terms will be there? 10 factorial, so many. And that too, the Cramer's rule, if you remember, it is ratio of two determinant, right? It is ratio of two determinant, and we have to find determinant for 2 times for each of the variables, and it will be super expensive to evaluate, to find out those terms and solve it. And so for more than 10 by 10, it is better to go for numerical techniques. So that's why you go for numerical techniques. Next is, I will be coming back here. Next is for functional space. We get two kind of problem: linear problem and non-linear problem. Linear problem always analytical solution possible, and there is no question of expensive. Okay, you have to just do it. There is no need to have any computer. So functional space, no need. Functional space does not require any computer. We just get the function. We just get the solution. But non-linear problem, you cannot get analytical solution. You cannot have analytical. Cannot have analytical or closed form solution. or closed form. So only way is numerical technique. Only way is numerical technique. So there are two aspects why we go for numerical technique. So Ax equals to B. If the system is a set of linear systems, it is not necessarily that always you can get analytical solution. Of course, Kamas anybody can get, anybody can even evaluate determinant for 100 matrix, but that will be super expensive because 100 matrix will be asking even to go to the MATLAB to do it, or even MATLAB I can tell you that even if you go for 10 by 10, MATLAB will just stand, you don't solve, you just try it. MATLAB cannot handle more than 10 by 10 matrix. It will be very, very slow. So in that case, of course, numerical technique is very powerful. Similarly, to O square, where you have differential operator, you can have ODs, you can have both PDs, and linear system analytical solution is possible, and nonlinear system analytical solution is not possible. In that case, one can go for numerical techniques. So let's start with Ax equals to B. First we discuss about Ax equals to B, and then we will be going for the function as well. So what we are planning to do for Ax equals to B, there are two ways. One is a direct method, and one is iterative method. So there are two ways you can solve Ax equals to B. Direct method, Gauss elimination, LU decomposition, which has got subparts which are Cholesky factorization. You can also have Thomas algorithm, the special cases. Also you can have something called Gauss-Jordan method. Okay. You might have heard these techniques, right? So Gauss elimination and decomposition has got the parts Cholesky factorization, Thomas algorithm, and one can have Gauss-Jordan. Iterative method is not a direct method, it is also used powerful. If you have very large matrix size, maybe 5,000, 10,000, 20,000, in that case sometimes iterative method is really helpful because direct method may not be that much powerful because of the number of operation power. So the iterative method actually divided as Gauss-Jacobi, Gauss-Seidel, and most general method actually we call as SOR and SUR. This SOR means successive over relaxation method. SOR means successive over relaxation method, and SUR means successive under relaxation method. Successive over relaxation method, and SUR means successive under relaxation method. SOR is successive over relaxation method, and SUR means successive under relaxation method. So we will be going to discuss the issues on the methods. So first we will be talking about the Gauss elimination method, and slowly we will be going for the LU decomposition, and finally we will end up with the iterative method. So first we will talk about Gauss elimination. What we do in Gauss elimination? Any idea? Gauss elimination we have learned in the school level, 7th standard. What we did in 7th standard, we were asked to solve this equation. 7th standard first we actually learned algebra, and that time we actually solved this 7th or 8th standard. What we do, we multiply this by 2, and then this is minus y equals to minus sorry. Yes.
Yeah, correct. Minus 3.
Okay, minus
Y equal to
y equals to plus 1. Right? So this technique is Gauss elimination method. We have done it already. That time they didn't teach that one. So this technique is Gauss elimination method. So what we do in Gauss elimination method? Ax equals to b, we transform this as ux equals to U is the upper triangular matrix. U is the upper triangular matrix. Upper triangular matrix. U is the upper triangular matrix. U is the upper triangular matrix. So we transform, and what's the advantage of this? If you look at x plus y equals to 2, 2x plus 3y equals to 5. What is the system? 1, 1, 2, 3, x, y, 2, 5. After doing the transformation, what we got? We got 1, 1, 0, 1, x, y. We got 2, right? So what we did that? We had the original equation, we got another equation y equals to 1. That's the thing. So this is upper triangular matrix. This is nothing but upper triangular matrix. So we also in school level, we have done this transformation. Ax equals to b to the ux equals to b prime. So these are b prime and these are b. So this is the easy demonstration of the Gauss elimination method. This is the easy demonstration of the Gauss elimination method. Now, how to, so this technique can be formalized, can be easily visualized in terms of the n by n algebraic system. So we can write as a11x1, a12x2, and a1xn equals to b1. a21x1 plus a22x2, a2nxn equals to b2. And we have an1x1 plus an2x2 plus annxn equals to. Okay. So what we got? A11, A12, A1n, A21, A22, A2n, AN1, AN2, ANN, X1, X2, Xn equals to B1, B2. Remember that this is our A matrix X and the B. And A matrix will be converted to U matrix, upper triangular matrix, right? Upper triangular matrix. So this will be converted. That means for making upper triangular matrix, these guys have to be 0. This guy have to be 0, and finally this guy be non-zero. So that we will have a diagonal which is non-zero. Above the diagonal, everything is non-zero. Below the diagonal, everything is 0. So including diagonal term, above diagonal everything is non-zero, and below the diagonal everything is 0. So that is the upper triangular matrix. So what we actually have for doing, we will have first this term 0. So we have R21, R31, and similarly we have Rn. What is R21? What is R21? R2 minus R2 minus R2 minus R1 by A11. Am I correct? R31 equals to R3 minus R1 by A11 into A31, and Rn minus R1 by A11, An1. Right? Am I correct? what I will do that, I will instead of put, yeah, you can actually put that also, no problem. So this is A11, A12, this is unchanged. This will be 0. This will be A22 prime. A21, you can say 1, 0, and it will be A2 and 1, A2 and, sorry, AN2, ANN, 1. Sometimes what actually happens, for the algorithm purpose, we always put 2 because we develop the algorithm purpose. This is the second step. This system is faster, so make it 2. For the algorithm purpose, we have to develop the computer algorithm, right? In computer program, this is your second step. First step is this one. This is your first step, original step. Original, I am putting serial number 1. Serial number 2 is this. So this is your first, you can say serial number. It's better for the computer program, otherwise you will get confused. Then you have to think about second step is your first. It's like that you have to, it is, I am just talking such that you can write a computer program. Okay? And then this will be unchanged. B1. What will be B2 minus? Which is B2 minus? B1 by? B3 minus? B1 by? A11 into A31. Bn minus? B1 by? Into AN1. Am I correct? Yes or no? So this is called as B22. This is called as B32. This is called as BN2. Am I correct? The entire term. Like this A22 and all those things. So there is a factor here. For this row, the factor is A21, A11. For the third row, the factor is A31, A11. For the nth row, the factor is AN1, A1. Right? So what I will do, I will store these factors. I will store these factors. I will store a matrix called L matrix. First is, I will say M21. So this is equals to M21. This is equals to M31. This is equals to M1. M21, M31, and we have M1. A222 is what? A22 minus A12 by A11 into A21. Or we can write A22 equals to A22 minus A21 into M21. Am I right? A12, right? Yeah. Correct? Yes. A32 will be what you tell me? A32 minus A12 into M31 is there. AN22 equals to AN2 minus A12 into same way here it is B2 minus B1 into M21, B3 minus B1. See, this B1 is common. Similarly, like A12 is common. B3 minus B1, M31, Bn minus B1 into Mn1. So if you store this, it will be very helpful for the computer program. So you got the first one. Then again, this guy has to be 0. Okay? So, then what actually happens? Next step, R3, 3, right? R2 I won't do any operation. It is a data. Next one onwards it will be 0, right? R3, 3 equals to R3, 2 minus what should I do? We have done already in BTech level. This Gauss elimination is not new, right? Everybody has done Gauss elimination earlier, right? Yes? Yeah. R2 2 divided by into A. All of you agreed with this? A 2 2 2. Correct? Agreed? Amit is completely gone. Your face is like that. What is that matrix? It will be 0, A32, A332 and so on. So A332 has to be 0. How to get it, make it 0? You divide it by A222 into multiply by A322. That means it will be R3 minus R22 divided by A22 into A32. That's what I do. Right? Yes? Nikita is completely lost. This is much easier than analytical technique. This is bookkeeping work. You are lost, right? A32 only. Yeah. Why I am taking? Did you understand why I took this one? Then, what is if I take the third row? Which is my reference? Which is my reference? I am asking a question. Second row is my reference. Correct. Then what actually happens? I have to make this guy A31, A32, A3n. I will write here A32, A3n2. Right? Okay, so what actually happens? I have to make this guy 0. How to make this guy 0? If I take up this row, divide by A32, multiplied by A32, A22, multiplied by A32, what actually happens? This guy has the same term as this term, this will be 0. So what I wrote, correct or wrong? See the situation. Okay? Yes or no? Okay. What will be there? You tell me. R43 will be what? R42 minus R22 by into A42 2. Other terms will be there. So what you will get? A11, A12, A1n, you won't touch it. 0, A222, A2n2, then 0, A32, sorry, A3n3, 0, 0, ANN3. Am I correct? Yes? Into x1, x2, xn equals to B1, B2, B3 what? B3 what? 2 or 3? 3? Bn3. Am I correct? What is the factor here? A32 by A222. Okay? Similarly A42. So what? How should I store? So here I will just put 1 because I am scaling with respect to that. Okay, I am storing here. So it will be A32. I will have M. This many factors will get. The factors will be coming from the third row. That's what I am saying. The factors came from the third row. The second row factor is 1. First row factor was 1. Right? Then what will happen? What will the factor here? M4. What is that? M43. And then and then finally. So this is the way I restore the factor also. At the end, what actually happens? My entire system A11, A12, A1n, 0, A222, A2n2, 0, 0, A333, A3n3, 0, 0, 0, A444, A4n4, and lastly you have ANN. What will be that? What will be that? At the superscript? N. So simple. Into x1, x2, xn equals to, we have b1, b22, b33, we have bn. Now we know that why I have put this R2. Otherwise, this nice form will not come and it is very difficult to do the computer program. And this is your exactly upper triangular matrix. Right? And how to do Gaussian elimination technique? Now xn will be what? bnn by nnn, right? And then this will be having, before that, we will be having only two terms. So, how to evaluate for the Gaussian elimination? Last step. I will delete this part. This is a B prime matrix. So how to do that? The last step, ANN n xn equals to bnn. So xn is bnn by ann. Previous equation is an minus 1 n minus 1 n minus 1 xn minus 1 plus an minus 1 n xn n minus 1 equals to b n minus 1 n minus 1. Am I correct? Previous equation. Then xn is already known, which is bnn by ann. So we have a n minus 1 n minus 1 comma xn minus 1 equals to b n minus 1 minus a n minus 1 n into b n n by a n n n. So we have xn minus 1, which is bn minus 1 into a n n n minus a n minus 1 comma n n minus 1 bn n a n n should be n minus 1 a n n n into a n minus 1 n minus 1 n minus 1. Am I correct? Yes. So like that it will go, and you can evaluate. You store it, subtract it, divide it. You store this one, then then next will be xn minus 2, xn minus 1, xn minus 1 is already evaluated, xn not evaluated, xn minus 2 can be subsequently evaluated. This is the call that this technique is called as back substitution. This technique is called as back substitution. This technique is called as back substitution technique. And what you got, you finally, similarly, the same thing will be. So that is the way you can actually evaluate the x1 to xn. Right? This is the way you can evaluate x1 to xn. Then what's the difference between Gaussian elimination and reduced composition? So you remember that we store two matrices, U matrix and L matrix. Right? You know what is called, so Gaussian elimination part is clear to you, right? I think I have explained enough. I tried my level best to explain to you the Gaussian elimination method. You can really do it. Then next is LU decomposition. What we do? This is Ax equals to, you decompose A matrix between as a multiplication of L matrix and U matrix. You decompose this as A matrix and L matrix, right? And then what actually happens? What you can do? You can write Ux equals to Z and Lz equals to B. So we are actually having two equations. Ux equals to Z and Lz equals to B. We have Ux equals to Z and Lz equals to B. And what are the U and L matrix? Upper triangular matrix and lower triangular matrix. How to get it? How to get it? Yeah, I know that upper triangular, lower triangular matrix. Even a thief can tell that there is no grade here. Upper triangular, lower triangular matrix correct. How to get this upper triangular, lower triangular matrix? So that means you have to constant upper triangular, lower triangular matrix such that if you multiply, you get it. And these are the upper and lower triangular matrix. That means Gauss elimination, decomposition both are same. Only thing is in decomposition method, we need this factor to be stored. If you store the factor, then it will be A matrix. Now, in the exam, I ask you to prove why this, if I do this L and U, can you get A matrix? So, L is here, U is here, why they are A? How to prove it? How to prove it? Why they are A? Why they are A matrix? So this is my L matrix and U matrix. I multiply, I get A matrix. How is it possible? How to prove it? This U matrix obtained from the row operation. We have done row operation. And you know that this kind of things we have already discussed. When you have done echelon form, we have seen that echelon form this also becomes 0. Then rank of the matrix will be less than the order of the matrix. Okay. This is the L matrix which is a lower triangular matrix. And my question is, I am claiming that this L is same L, this U is same U. How to prove A equals to L? How to prove that? So interesting. You can see that we have done this by Gauss elimination. We have stored it. We have stored this and this multiply. If you multiply this L and U, you get A matrix. How is it possible? How is it possible? How is it possible? Okay, maybe the possible exam question. Maybe the possible exam question. Maybe I can give you 3 by 3 matrix and you have to demonstrate that it is possible to have this A and U. And remember that the L matrix diagonal is 1. The L matrix diagonal is 1. What's the advantage of value decomposition method? What's the advantage of value decomposition method? See, Gauss elimination is very straightforward. A kid will say, okay, I'll go for Gauss elimination. Why to do this L and U and all those kind of stupid things, so much 2 steps and all. What is the advantage of value decomposition over Gauss elimination? Gauss is very straightforward, right? Ax equals to B, you compute Ux equals to B prime, and then from the last row you get the solution. Straightforward. You don't need to worry about L and U and these 2 equations. Why to suffer in life? Why to suffer in life? Any idea? Okay, the answer is, if you look at this system, doesn't matter which B you have, this system is unchanged. Okay? And this L is depending on this factor, which does not have even have B. So that means this method is very powerful. When we have a system Ax equals to B, where only B is changing, but A is fixed, then if you store U and L and only using this equation, equation, you can get the solution. This will remain unchanged. And this operation is very straightforward. And only so basically, what you can see that this ux equals to z remains invariant, and I can actually show you that in fact this out of scope for this course. The number of operation count in a decomposition is much smaller than the number of operation count in the Gauss elimination. But the other two sets, this ux equals to z does not depend on the what is b. This is remains unchanged. Once you calculate, it is stored in the computer. Okay, and this will come from here, and and that's it. So once you solve this one, and then you can actually get the answer. Any question, doubts? Any doubts here? So first we do that. First, what we do? Lz equals to b. We solve it. Get z, and the next step is ux equals to z. Already known from here. U is here, and x can be operated. That's the way actually one can actually do the stuff. Okay, so we have seen that LU decomposition is nothing but the companion of Gauss elimination method, and it can be proved that A and U matrix are actually there. In fact, I can give you some L matrix and some U matrix. I ask you to construct A. It is easy. But if I say I am giving A matrix, how to construct A and U? You have to do that, and then you have to multiply and try to prove that A and U is giving the A matrix. Okay, so enough of the Gauss elimination method and LU decomposition method. Next is Gauss-Jordan method. What is Gauss-Jordan method? What is Gauss-Jordan method? Gauss-Jordan method. What is that? Do you remember? Need to find inverse of a matrix. Sometimes people will say, okay, Ax equals to B. My solution is x equals to A inverse B. So if I find A inverse, I can multiply with B and get the solution. It's a very expensive technique. I never use it. But you should all know that. So what actually, how to find the inverse? How to find A inverse? By Gauss-Jordan method. How to do the Gauss-Jordan method? You need to have the augmented for matrix, right? Do you remember? Augmented? What you augment to? What is B? A, B. I am finding inverse. There is no question of B. 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 Ax. I don't need x. AI. Yes. Then what do you do? With AI, so you have A11 to A1n, A21 to A2n, AN1 to ANN, 1, 0, 0, 1, 0, and 0, 0, 1. Next step. I will not discuss here because this method is not useful. I don't like it. But you all should know that. Then you do the what? You do row operation. Okay? And try to make this a what? Your identity matrix. Automatically it will be the inverse. That is a Gauss-Jordan method. Very, very expensive method. And I will say that immediately don't use this method. So if you don't learn, it's okay. Good for you. If you know, fine. If you don't know, that is also very fine. So I will not recommend you use this method because if I want to teach you the number of operation count or block, this is very, very expensive. Next there are some parts of the decomposition method. Before finishing the part, one is Cholesky factorization. What is Cholesky factorization? If matrix A is symmetric, then what actually happens? It is proved that A equals to A del transpose. How to prove that? A equals to A del transpose. Matrix A is symmetric, then A equals to A del transpose. And what will be the algorithm then? What will be the algorithm then? Matrix A equals to A del transpose. What will be the algorithm then? What I am saying that you obtain the U matrix, right? And L matrix is what? With respect to the factors. That means each of the factors is nothing but the other part. So row will go to column, column will go to row. Okay, if you remember that, so L matrix will be like this. L1 1, then all 0. L2 1, L2 2, all 0. And last will be Ln1, Ln2, Ln. These are the factors. And U matrix will be having A11, A12 and all those things. So how to prove that? That means what? That U matrix has all the entries in the first row. And here, first column has all the entries. So that means this will be all equal to, this will be equal to A11, A12, A1n. How to prove? Okay, I am giving open questions. These are the questions I am going to ask. How to prove that L11, L21? Because your U matrix is what? A11, A12, A1n. 0, A222, A2n. 0, 0, A333, A3n3. And lastly, it is ANN. I am saying A is symmetric. That means what? Aij equals to Aji. We are not symmetric matrix, real symmetric. No need to have any complications, no need to have complex quantities. That are real symmetric. That means this will be equals to this. So L1 equals to A1, L21 equals to A12. And how to prove it? How to prove it? That's my question. Next is this one. So A222 is nothing but L22. Similarly, A2n2 is nothing but Ln2. How to prove it? How to prove it? So this is the another question. So to pick up some 3 by 3 matrix, pick up the 3 by 3 matrix and try to prove the U is nothing but L transpose. U is nothing but L transpose. These are the possible questions in the exam. I will say that, okay, take 3 by 3 system. 3 by, I won't ask 4 by 2. Maximum 3 by 3 I ask. 2 by 2 is very simple. That only US guys only do 2 by 2 because they don't understand 3 by 3. Since we're in India, we do slightly better 3 by 3. So we'll go for 3 by 3 matrix and I will ask you how to. I'm just giving you questions. Each class of numerical I'll give you possible questions and the questions will be coming from that. So how to prove this will be this will be this, and similarly the last term A will be that one. Okay. How to prove? Next is Thomas algorithm. How to prove Thomas algorithm? What is Thomas algorithm? Any idea? What is Thomas algorithm? Thomas algorithm is valid for tri-diagonal system. Thomas algorithm is valid for tri-diagonal system. Thomas algorithm is valid for tri-diagonal system. So let's look at some tridiagonal system. Matrix A, A1, C1, 0, B2, A2, C2, 0, and then 0, 0. Then we have B3, A3, C3, 0. Then all 0. And last row we have Bn and An. That means this is your subdiagonal, this is your diagonal, and this is your super diagonal. Super diagonal will be over end here. So this is called tridiagonal matrix. Where this kind of matrix can occur? Mostly in finite difference method. So this matrix is a resultant of finite difference method. Simple finite difference method, this matrix will occur. How to solve by LU decomposition? You solve by LU decomposition. The question is, what will be your L matrix and U matrix? What will be your L matrix and U matrix? How to derive the L matrix and U matrix? And all entries will not be there. Okay? How to derive the, so what will be your L matrix, U matrix? Are they tridiagonal matrix? What it will be? If L matrix and U matrix are equal, will they be tridiagonal matrix? Any guess? A matrix is tridiagonal. What will be L matrix and U matrix? How many terms will be there along the diagonal? Any idea? How many terms will be there along the diagonal? How many terms will be there along the diagonal? How many terms will be there on the diagonal? L matrix is what? Lower triangular or upper triangular? Okay. So that means we know that diagonal nothing will be there for the upper triangular matrix. Above the diagonal nothing will be there for the lower triangular matrix. How many diagonal terms are there? 3. What is your speculation? What is your guess? Lower triangular matrix, how many diagonal terms will be there? 2. Similarly for the below, upper triangular also there are 2 terms. How to get those terms from the LU decomposition? That means before ending, I will give the L matrix, which is 1, 1, 1, beta 1. Sorry, beta 2, beta 3, and beta n. This is all are 0. And U matrix, it is alpha 1, C1, alpha 2, you have alpha n, and you have Cn minus 1. All are 0. What are alpha 1, alpha 2, alpha n, and beta 1, beta 2, beta n? That can be done similar manner for the LU decomposition method. And how to develop the algorithm for solving. How to develop? Algorithm means I need to generalize term. Any term will be like this. That's called algorithm, right? That is called algorithm. If you want to know what is called algorithm, go to Google, search it. I cannot teach everything in the class, and these are all taught in the BTech first year or second year. How to develop the algorithm? What will the error term? Okay, so this is one of the possible questions for the Thomas algorithm. Next part, and all these questions can be addressed if you look at numerical techniques books. You look at the book by S.K. Gupta, Numerical Techniques for Engineers by S.K. Gupta. The book is available in the library. You may not get the answer what I am actually asking. You have to really